Hello, students. We're about to start lesson 3-4, Investing in Yourself. Our learning objectives is to understand different student loan options, to compute interest and monthly payments on a student loan, evaluate the effects of capitalizing interest, analyze various aspects of a mortgage, compare two mortgages of different lengths, and prepare an amortization schedule. Okay, here at the bottom, it says student loans. There are three basic types of loans that most undergraduates might consider. Federal loans made by the government, federal loans made by banks or other lenders but guaranteed by the government, and private loans. Every student's first choice should be the federal loans due to stability. The interest rates are fixed for the life of the loan and are regulated by Congress, so you're unlikely to end up with a nasty surprise somewhere down the line. There are, however, limits on the amount that can be borrowed for one student through federal loan programs, and private loans might be the only alternative for an especially expensive education. Other than the length of the loan, the big difference between student loans and other installment loans is that the payments are typically deferred until after graduation. This makes perfect sense, as in many cases, students aren't working enough to make the money required to keep up with payments. So that's a pretty good deal, but it comes with a catch. In some cases, interest will accumulate on your loan while you're in school, even though you're not making any payments. This can increase the principal balance considerably. The loan term can vary depending on the amount borrowed, but the standard term is 10 years with payments deferred until 6 months after graduation. Now we move on to the next page. It says interest on student loans is simple interest. The interest accrues only on the principal balance, not on previously accrued interest. So while the student is still in school, the amount of interest that accrues each month remains constant. The interest is calculated using the simplified daily interest formula, which we can develop using things we know about simple interest. If the principal balance of a loan is 6,500 and the interest rate is 6.8% annually, how much simple interest will accrue in 1 year? So we can use the simple interest formula here, which is I equals PRT. I we know is interest. The principal we're told is 6,500. The rate is 6.8%, which is 0.068, and the time is 1 year. Now we could put this in our calculator. So when we put this in our calculator, we would take the 6,500 and then multiply by the 0.068 and multiply that by 1. So our interest for the year would be $442. Okay, so now it says, why does it make sense to use 365.25 days in a year for financial calculations? That is because every 4 years we have a leap year, which adds an extra day. So 365.25 accounts for the extra day in calculations. Now, number 3, it says using questions 1 and 2, find the daily amount of interest that accrues on a $6,500 loan. Make sure you explain how you got your answer. So we would take the interest from a year, which is $442, and divide it by the days in a year, which is 365.25. Now we'll put that in our calculator. We have 442 divided by 365.25. And that gives us $1.21 per day. And it says for us to explain how we got the answer. So basically, divide the interest for 1 year by the amount of days used for calculating financial calculations. So that's basically what we did. We divided the interest for 1 year by the amount of days used for calculating financial calculations. Okay, number 4. How much interest accrues in a month? Be careful. Now, the reason why they say be careful is because we know there are 4 different values you could get for days in a month. We know we could get 31 days, we could get 30 days, we can get 29 days, and we can get 28 days. That's why they say be careful. It just depends on the month. So we would take these days and multiply by the daily amount of interest. And when we multiply these out, we of course will get different values. So this would be $36.30 for the 30 days, $35.09 for 29 days, $33.88 for 28 days, and of course the 31 days was $37.51. All right, so it says here, the simplified daily interest formula, daily interest amount is equal to principal balance times interest rate divided by 365.25. Monthly interest, well, it tells you this here. Monthly interest amount is daily interest amount times days in a month. Okay, now we move on to the next page. We look here at problem number 5. It says, for that $6,500 student loan we've been working with, if you start school in August, graduate in May, 3 years and 9 months later, and payments begin 6 months after graduation, how much time will pass while interest is accruing? So let's take a look here. It tells you here that this was 3 years, 9 months. 3 years, 9 months. But payments begin 6 months after graduation. So if we add 6 more months here, this will give us 3 years, 15 months. Now, as we know, it's 12 months in a year. So we could take this 15 months and pull 1 year out of it. So if we pull, let me write it over here. So we had 3 years, 15 months. We pull out 12 months here and convert it to 1 year. So this will give us 4 years and 3 months. So this would be 4 years, 3 months. Okay, number 6. Write out the months that come after the last full year ends, then the number of days in each of those months. Okay, so if you look here, you graduated in May. All right. So what happens is this here. You're going to go okay, it's 4 years from when you graduated. So 4 years from May would still be May. 3 months after that would be June, July, August. So your first payment will actually happen September, and then October, and then November. would be your next 3 months. So September is 30 days, October is 31 days, and November is 30 days. So let's go back there again. You graduated in May. 4 years, May to May, that's 4 years. Then it's 3 months later. Then you will have June, July, August. And then the next 3 months. Oh, you know what? Let me backtrack. I made a little error here, but I'm still going to correct this. Okay, they said write out the months that come after the last full year ends, then the number of days in each of those months. Okay, we were supposed to go from August because we're talking about not when you graduated, but when you actually started. You started in August. So if you do 4 years, August to August is a year, and then after 4 years, you will still wind up in August. So you have to do the 3 months after the 4 years, which take you to August again. So then that would be your September, October, and November. Sorry about that, but that's how that is supposed to go. So again, 4 years from your start date of August, you will end up in August, and the 3 months after that will be September, October, November. Now it says find the amount of interest that accrues in the number of full years from your answer to question 5. So we know it's $442 a year, and it's 4 years, so it'll be $1,768. Now that's how much interest will accrue for those 4 years. Now number 8, write the amount of interest for each of the months listed in question 6. Your answer to question 4 will come in very handy. So we will have September, October, November. And we could go back here to page, what was that? Page 252 at the bottom. Because remember, September has 30 days. So that'll be $36.30 would be how much interest accrued. October has 31 days, so that'll be $37.51. And then November has 30 days as well, so that'll be $36.30. Okay, so now this will be the amount of interest that accrued these particular months. Now for number 9, it says how much total interest accrues before payments begin. So we have $1,768 plus the $36.30 plus $37.51 plus $36.30. Now we add all of these up, put these dollar signs here, and that will give us $1,878.11. So that's how much interest accrues before you even make your first payment. So now we come here to the back. When interest is covered by the government while the borrower is still in school, a student loan is called subsidized. Now those, if you're going to take out a student loan, those are the best ones to take out, the subsidized loans. If interest is added to the principal while the borrower is in school, the loan is called unsubsidized. For the loan in questions 1 through 9, the students will have saved $1,878.11 by acquiring a subsidized loan. When monthly payments begin on a student loan, they're based on the principal balance at that point in time. These payments can be computed using the following formula, which should look familiar. It's exactly the payment formula we studied in lesson 3.3. We just thought we'd be nice and recopy it rather than making you page back. You should probably, okay. Also, since most student loans have a 10-year term, we took the liberty of adapting the formula to that situation. Again, okay, if you look here, when it's adapting to the 10-year term, this is where this negative 120 comes into play. and we'll get to that a little later. All right, we come down here to number 10. It says, reminder, perform the calculation in one step if you can. If not, don't round too much. Always use at least 4 decimal places, and more than that won't kill you. Okay, number 10. For the loan in questions 1 through 9, what is the principal amount at the time payments begin? This includes the original amount borrowed plus the amount of interest that accrued until payments started. So remember, we initially borrowed $6,500. But then when we did the interest that accrued, it accrued $1,878.11. And that was back on page 253, what we got here for problem number 9. Now, when we add these two together, our new principal balance will be $8,378.11. So this is what everything is going to be based on when we start making our payments. Now it says find the monthly payment on the loan. So we're going to use this formula here. So we had M is equal to P times the rate over 12 divided by 1 minus 1 plus R over 12 to the negative 120 power. All right, now we're going to do some substitution here. So the principal would be $8,378.11 times the rate is 0.068 over 12 divided by 1 minus 1 plus 0.068 all over 12 taken to the negative 120 power. Now we're going to put this in our calculator. So now we have now I just had a little technical difficulty, so now we can start. It looks like it's still back here. Let's see. Okay. Now we can start typing in these values. So we had 8,378.11. Oh, it's not coming up. Type that up here. $8,378.11. Let me see. Times 0.068 divided by 12. Our denominator is 1 minus the parenthesis 1 plus 0.068 divided by 12. Close our parenthesis. And now we take this to the negative 120 power. So this will give us a payment of $96.42 a month. Okay. So that's how much your student loan will cost you as far as your monthly payment with the starting amount of $8,378.11, and the interest is 6.8% for 10 years. Okay, so now we move on to the next page. It says here, for the student loan we've been working with, the payment while still in school would simply be the amount of interest that's accruing, which you already calculated. For reference, in the space below, write the amount you pay in an average 30-day month, as well as the total amount of interest you pay before regular monthly payments begin. Okay, so we want to do a 30-day month. And we know the interest for 30 days is $36.30, which we got on the other page. And then we have the total interest before payments. Total interest before payments is $1,878.11. Okay, number 12. It says with interest not capitalized, The principal balance on the loan would still be $6,500 when full payments start. Find what those payments would be. Okay, so we had M is equal to P times R over 12 divided by 1 minus 1 plus R over 12 to the negative 120. Now, we'll replace the principal with 6,500. Your R would still be 0.068 over 12. And then we will have 1 minus 1 plus 0.068 over 12 to the negative 120 power. Now, we will go right here to the calculator and we'll substitute in the 6,500. That's the only thing that has changed. Everything else was the same. So now your payments would be $74.80 if your loan remained at $6,500 instead of going up by that 1878.11. Now 13, you make 120 payments on the loan since you had 10 years to pay it back. Use your answer from question 12 to find the total amount of money that you pay on the original $6,500 loan. Hint, don't forget the amount you would have already paid while in college. Okay, so you have $74.80 times 120 payments. Because remember, 10 years of payments, 12 months in a year, times 10, that's 120 payments you would make. Plus the $1,878.11 in interest you would have prepaid. And when you add all of this up, it'll be $10,854.11. That's how much money you would have paid over your 10-year loan. Now, the key question when studying whether or not to capitalize the interest, if interest is capitalized after paying nothing while in school, you'll end up making 120 payments of the amount you found in question 11. So how much money would you save by paying for the interest while still in school? More importantly, discuss with your group whether or not you think the amount saved would make it worthwhile to scrape together those payments while in school, then write your thoughts. So we got before, with interest added to the original principal, it came out to be $96.42 a month payment for 10 years. So we'll take the $96.42 times 120, and that would give us $11,570.40. That's without us making any payments. So now to find out how much you would save by making the payments as you go along, you would take this $11,570.40 minus the $10,854.11. And when you subtract this out, you will save $716.29 over the course of 10 years. Now that's not per year. This is how much you would save in a year. So basically, you're paying about $70 extra a year without paying interest while in school. So for most people, it would not be worth it, not be worth scraping money together while in school to save about $6 a month. Okay. And the reason why it wouldn't be worth it for most people is because as a student, most people do not earn that much money. So it would be a big financial burden to them to have to scrape up that money. Now, home buying. It says for many people, the day they buy their first home is one of the proudest days of their life and one of the scariest. There is nothing that compares to the feeling of looking at a house and knowing that it's all yours. But the buying process is tremendously intimidating. There are dozens of documents to sign, and the sheer numbers involved are enough to make almost everyone wonder if they're making a colossal mistake. The most common home loans are paid over a 30-year span. That's a major commitment and one that no one should enter into without an understanding of the mathematics that go into the process. In the remainder of this lesson, we will study that math, hopefully helping you to become a well-informed home buyer. Maybe you're thinking, dude, I'm a college student. Buying a home is like a million years away. If so, you will be surprised at how quickly that million years passes. I surely was. A mortgage is a long-term loan where the lender has the right to seize the property purchased if the payments are not made. Homes are the most common items bought using mortgages. The most common mortgage term is 30 years, but they are widely available in terms from 15 to as many as 50 years. There are several types of mortgages. With a fixed rate mortgage, the rate of interest remains the same for the entire term of the loan. The payments, usually monthly, stay the same. With an adjustable rate mortgage, the rate of interest may fluctuate, increase and decrease during the period of the loan. If you opt for an adjustable rate mortgage, it will start out with a lower interest rate than a fixed rate loan of the same length. Okay, now 15. It says, discuss the pros and cons of fixed and adjustable rate mortgages. All right, now I want to talk to you all slightly about that because there are a lot of pros and cons of the fixed and the adjustable rate mortgage. So I'm just going to do one pro and one con for each. Okay, one of the pros of a fixed mortgage is that the payment stays the same. The payment stays the same for the life of the loan. Okay, the con, rates could go down, but yours will not. Okay, now the adjustable, and I'll just put it, it's called an ARM, the adjustable rate mortgage. That's what a lot of people call them. The adjustable rate mortgage, the pro, lower payment at start of loan. The con, payments can go up depending on interest rates. So back in, I think that was 2007, 2008, a lot of people had adjustable rate mortgages and they end up losing their homes because the payments got outrageous because they were going up because of the interest rates. So that was definitely a con. Now it says discuss the pros and cons of buying a house compared to renting a place to live. Okay, I'm just going to do one. Buying a house. Okay, the pro. You have privacy. A con. You pay for everything. Okay, renting. A pro. You do not have to pay for everything because some places you rent, well, I'll just say most places you rent, you don't have to pay a water bill or property tax. Some places don't even have you pay electric, or some places don't have you pay gas. It just depends on where you're renting from. But a con is that you have no privacy because the landlord could come in and out of your place, and you can have noisy neighbors across the hall from you. So it just depends. All right, so we need to go on to the next page, page 257. So it says here, one of the most useful but frightening things about home buying is calculating how much money you will actually pay over the life of the loan. Let's see how that might work for one family. The Petty's family plans to buy a home for $224,900 and has been offered a 30-year mortgage with a rate of 5.5% if they make a 20% down payment. Calculate the down payment and the amount they'll have to borrow. So the down payment will be $224,900. And the down payment, they're going to put 20% down. So it'd be 0.20. And when you multiply this out, it'll be $44,980 will be the down payment. All right, now they want us also to calculate how much we will borrow. So we'll take the cost of the home minus the down payment, and that will give us $179,920 that needs to be borrowed. Okay, number 18. It says the monthly payment on the loan will be $1,021.57. How much will the Pettys actually pay for their $224,900 home? Now we're assuming, and it says here in the directions, that it's a 30-year mortgage. So first we'll take the 30 years times 12 payments a year. So it'd be 360 payments. Now we're told that it's $1,021.57 a month, and we'll multiply that by 360 payments. But we also will add in the down payment we put on the property. So they will be paying a total of $412,745.20. So that $224,900 home almost doubles in price of how much you would pay over the life of the loan. Okay, now at the bottom it says when you apply for a home loan, the lender will tell you what your monthly payment will be. And if you're an incredibly trusting sort, that might be good enough for you. For most of us, though, a double check of the quoted payment will be a big comfort. In addition, Knowing how the payment is calculated makes it quite a bit easier to understand the factors that determine how much you will pay. Better still, it would allow you to compare mortgages with different rates, down payments, and lengths. So let's have a look at computing monthly payments. Okay, now we come here to the back. It says in the space below, recopy the formula that we use for computing monthly payments on a student loan with a term of 10 years. Then describe the significance of each part of the formula requested below. So we had M is equal to principal times the rate over 12 divided by 1 minus 1 plus the rate over 12 to the negative 120 power. Now P we know is the principal. R is the annual interest rate. Or we could have just said rate. And then 12 is the number of payments per year. Now number 2, where do you think the 120 comes from in the formula? It's the number of years multiplied by the number of payments. Okay, number 3. It says, using your answers to questions 1 and 2, adapt the student loan monthly payment formula into a general formula for finding the periodic payment on a loan with principal value P, annual interest rate R, term T in years, and end payments per year. Now, first of all, let's go back up here to this formula. These 12s represent how many payments you make in a year. So that would be our N. So I could put this here, N is equal to, and then this is 12 number of payments per year. So we would know where this N is coming from. Now here, because this is a 10-year loan, we know that our T is the number of years. So T is number of years. Now, to write out a general formula using this knowledge, we have M is equal to P times R. That 12 up here is actually N. So it'd be R divided by N all over 1 minus 1 plus, and then we will have R over N, and then it'd be negative. Now we know N is the number of payments times T. So this is the generalized form of the formula we use for the student loans. So now we could do any monthly payment problem with that formula. So we go here to number 4 on the next page. Earlier we studied a loan obtained by the Petty's family with these terms. Purchase price is $224,900, 20% down payment, 30-year mortgage with a rate of 5.5%. The monthly payment was $1,021.57. So, how much higher would the monthly payment be if they put only 10% down? This would also raise the interest rate to 5.8%. So we have $224,900, and we'll multiply it by the 10%. So our down payment would be $22,490. That'll be the down payment. Now our new principal, and I'm just going to write that here. Our new principal would equal to the $224,900 minus the down payment. So our new principal would be $202,410. Now we want to do our new monthly payment. So we have M is equal to P times R over N divided by 1 minus 1 plus R over N to the negative NT power. Now we're going to substitute. Our principal is 202,410. Our rate, we're told that our interest rate now is 5.8%, so it'd be 0.058 all over 12, because it still will be monthly payments, all over 1 minus 1 plus, the rate is 0.058, still over 12, to the negative, and we're told here that this is still going to be a 30-year loan. So it'd be a negative, N would still be 12, and T would be 30. So we know that that'll end up being a negative 360. So we could put this in our calculator. We could go back here. We already have the monthly formula set up. So all we have to do is just change a few numbers here. Our principal is 202,410. Now our rate is 0.58. So we go down here to the bottom. Same thing for our rate, 0.58. And then our time here, our exponent, is supposed to be a negative 360. So that would mean that our payment will be $1,187.65. Now, when we want to find the difference here, the difference between this payment and the payment we came up with back on the previous pages. Let's see, where did we come up with the payment? Oh, actually, we didn't come up with the payment. The payment was given to us in the directions up here. The payment was $1,021.57. So we would take this calculator and take 1187.65 minus the 1,021.57, and that would give us, this would be $166.08 higher. Okay, number 5. How much more would they end up paying over the life of the loan? So we'll take the $1,187.65 times 360, and that would give us $450,044. Now, we have to add the down payment as well. The down payment was $22,490. So we will add that up. As a matter of fact, let me clear up a little space here. So we will add this up. We will add a $450,044 plus the $22,490. So this will give us $472,534. Okay, next. And then we would take this value here and we would subtract how much we paid for the other, for the 20% down. Now we need to go back to where we found out the actual cost. If you look back on page 257, the actual cost was $412,745.20. So we would subtract these two values. So 472,534 minus 412, 745.20. So that means that you would pay $59,788.80 more. By only putting down a 10% down payment and having that higher interest rate. Okay, number 6. Now let's examine the term of the loans. If they choose a 15-year mortgage with 20% down at 5.5%, what would the monthly payment be? So using that same formula, now we already know what the 20% down ended up giving us. That was on, if you go back and look, that was actually on page 257, problem 17. So our principal, well, I'll write the formula out again. So this is the formula we're using, even for the 15-year mortgage. So it'll be $179,920 times the rate will be 5.5% all over 12. This will be 1 minus 1 plus 0.055 over 12. I'll take it to the negative. N is 12 times 15. Now 12 times 15 will actually give us a negative 180, but we'll be fine with that. Now we're going to put this in our calculator. Now remember, since we're using the same formula, we could just substitute in some of the values. So we have $179,920, and then our rate would change. It'll be 5.5%. Our rate would change here to 5.5%. And then our exponent, instead of being 360, it'll be 180. So now our payments would be $1,470.10. Now it says, how would their total cost compare to the other two options we studied? Which mortgage do you think is the best choice? Okay, so we'll take the $1,470.10 times 180. So we'll put that in our calculator. So 1470.10 times 180. And then we have to add on our down payment. Remember, our down payment what's that? 44,000, I think. Our down payment is listed back on page 257, problem 17, which was $44,980. So that means that it would cost $309. I was supposed to put, let me rewrite that. So it's supposed to be 1470.10 times 180 plus the 44,980, which will give us $309,598. Okay, now we're going to compare this to all the rest. So we will go with the first value we did at the 20% and subtract this 309,598. And when we subtract that, that will give us $103,147.20 that we would save. And then when we take the 10% down payment, that will let us save $140,446. Oh, wait a minute. This is off slightly. That shouldn't be 140,000. Let me subtract that. So it'd be 450,044 minus 309,598. Oh yeah, I was correct. Okay, so it's $140,446. Now, this question that's asked about what is the best choice, that's kind of subjective, because if you have the money, the 15-year 20% down would be the best choice because it saves money and you would be done 15 years earlier. So yeah, that would be the best choice if you had the money. But if you don't have the money, then that wouldn't be the best choice for you, because you wouldn't be able to afford it. Okay, now they have here where we could compute an amortization table or schedule, and it tells you the different steps. We're going to go through the steps here so you could just follow along. It says in the next group of questions, we'll use these steps to compute the first 3 months of an amortization table for the Petty's loan. Principal $179,920, rate 5.5%, monthly payment $1,021.57. A template for the table is included in question 12. Fill in the information as you find it. Okay. Calculate the interest for the first month of the loan and put it into the interest column of the table. So interest is equal to the principal times the rate, but we want to know the first month. So we would divide this by the number of payments or by the number of months. So the principal is $179,920 times 0.055 divided by 12, because they want it for 1 month. When you put this in the calculator, it'll give you $824.63. Now we're going to put this in the table in just a second. Let's just finish 8 and 9, and then the next page will have the table. Okay, number 9, it says subtract the interest from the monthly payment to get the amount paid on the principal, then put the amount in the appropriate column in the table. So remember, our monthly payment is $1,021.57. This month's interest is $824.63. Now, when you subtract this, this is how much will go to the principal to make the loan smaller. So, okay, now we took care of problems 8 and 9. Now we're going to move on to the next page. Now the table that we're looking at here is down here in problem number 11. So I'm going to put in what we have here for problem number 8 and 9 from the previous page. So the interest is $824.63. The payment on principal was this $196.94. And then the balance of the loan, we will need to subtract that off. So it's $179,920 minus the $196.94. So the balance of the loan would be $179,723.06. Okay, so we don't need that anymore. All right, now for number 10, it says calculate the new balance of the loan by subtracting the payment on principal from the original principal, then put it in the last column. So we kind of skipped a step here, but we could write it here, $179,920 minus how much went to the principal, which is $196.94. So that would give us $179,723.09. Now for number 11, repeat the previous steps for the next 2 months. Do your calculation in this space. Then put the results in the table. All right. So for the second month, we first find the interest. We'll take this principal, $179,723.09. Oh, you know what? I'm sorry, it's supposed to be 06, not 9. 06. All right. So now this will be the principal. And we will multiply this by 0.055 divided by 12. So As far as I know, okay, I didn't type that in here. So let me type that in here. So we have 179,723.06 times 0.055 divided by 12. Oh, all right. I made a mistake and typed it at the top. It's supposed to be in the next one. Okay. So let me retype that. 179,723.06 times 0.055 divided by 12. All right. So that would give us 823.73. That's how much interest it would be. So we could write that down here, 823.73. That's the interest. Now, what we want to find next, we want to find out how much is going to the principal. So we have $1,021.57 minus the $823.73. So we'll put that in our calculator. 1,021.57 minus 823.73. So that will give us $197.84. So it'll be $197.84. Okay, now the next step, we want the balance on the loan now. So we'll take the 179,723.06 minus the 197.84. So 179,723.06 minus 197.84. Okay, so now we're still in the 179,000. So we got $179,525.22. So now we basically repeat this process again. So now we would go to month 3. So the interest is 179. Interest is equal to 179,525.22 times 0.05 over 12. So we could just come up here and just make some changes here. That's why I love Desmos. So you don't have to reinvent the wheel. 525.22. Okay, so our monthly interest would be $822.82. So then the payment on the principal, we'll take the 1,021.57 minus 822.82. So that'll be 198.75. And then we would take that from the principal. So we have 179,525.22 minus 198.75. Okay. So 179, it's that 525.22. Then we have minus, it'll be 198.75. So that would give us 179,326.47. All right, now number 12. Well, before we go to number 12, if you notice, these values were going down. Each month, more is going to the principal, which is making the loan go down. It says number 12, what does this table say about what the bulk of your payment goes to when you begin making payments on a mortgage? What about near the end of the term of your loan? Okay, basically, Early on, the majority of the monthly payment goes to interest. Near the end of the loan, most of the monthly payment goes to the principal. And this is basically it from section 3.4. Remember, you have to complete your check assignment for today, and have a happy Thanksgiving, and we'll see you again on Monday. Have a wonderful weekend.